Hi, physiology students, and welcome to Module 3. We'll start with Chapter 11. This is all on the endocrine system and hormones. Sometimes the endocrine system isn't covered in detail in physiology class, so we are not going to cover it in detail. I'm going to give you the whole PowerPoint because I want you to have all of the supplemental information. But what I'm going to want you to know in terms of the endocrine system is mainly just the types of hormones and what they do. And we'll go over the ones that I want you to know. So an endocrine gland is a ductless gland, and this just means that it secretes hormones directly into the blood. Hormones are carried to their target cells, having receptors for those hormones. And many organs secrete hormones other than those discussed in this chapter. So your heart, your liver, your kidneys, and adipose tissue will also secrete more hormones that we might cover when we get to those body systems. Hormones are incredibly important for regulating body metabolism, growth, and reproduction. So these are the major endocrine glands. You can see here the hypothalamus, the pineal gland, and then the hypothalamus controls the pituitary gland and what it secretes. So those are located in the brain. Then the thyroid gland is located in the larynx, your voice box. You have your pancreas. Here's a look at your pancreas. It has little pancreatic islets, which are specific cells designed to secrete insulin. Adrenal glands are on top of the kidneys, and then your ovaries and testes will secrete hormones depending on the gender. So this is a basic or a partial listing of the endocrine gland and the major hormones they secrete. It also tells you the primary target organs and the primary effects. This is probably a good chart to study, knowing the basic endocrine glands and what major hormones they secrete. We'll kind of go through this chart, but outside of this chart, I won't have you guys need to know too many other details. Chemical classification of hormones. I'm going to skip over this. It just tells you how the hormones can be classified, basically, and how they look. So this takes you through the different hormones, how many amino acids are involved with them, and then the primary effects. So you don't need to know the chemical classification for the different hormones. Hormones can be polar or non-polar, and that just means they can dissolve in water or they cannot. This is important in pharmacies or pharmacists because they don't want to give you a drug that won't be able to be dissolvable, or something that would interact with something else. Prohormones and prehormones are usually inactive. They must be cut and spliced together to be activated. An example of that is insulin. Other examples would be testosterone. And a big example of this is in your thyroid hormone. The inactive form is T4, and it has to be activated to T3 to its active product. Hormones and neurotransmitters both interact with specific receptors, and these binding to a receptor causes a change within the cell. A target cell is usually responsible to several different hormones, and hormones can be antagonistic, synergistic, or permissive. And how a cell responds depends on the amount of the hormone and the combination of all hormones. So a synergistic effect will occur when two or more hormones work together to produce a particular effect. They may be additive, as when epinephrine and norepinephrine each affect the heart in the same way, or they could be complementary, as when each hormone contributes a different piece to an overall outcome. So for example, producing milk requires estrogen, prolactin, and oxytocin. A permissive effect occurs when one hormone makes the target cell more responsive to a second hormone. An example of this is exposure to estrogen makes the uterus more responsive to progesterone. This is important for a developing fetus in a woman. Increased secretion of parathyroid hormone makes the intestines more responsive to vitamin D3 and calcium absorption. And then hormones can have antagonistic effects where they will occur in opposite directions. So insulin and glucagon are antagonists, meaning they both affect adipose tissue, but in different ways. Insulin stimulates fat storage, so taking sugar out of your blood and storing it as fat, and glucagon stimulates fat breakdown or putting sugar back into the blood. I'm going to skip over hormone half-life. That's just the time required for the plasma concentration of a given amount of hormone to be reduced in half. And I'm gonna skip over many of these. I'm especially gonna skip over probably mechanisms of hormone action. You don't need to know any sort of mechanisms of hormone action. All I really want you to know, and probably what's most important, is just kind of what these hormones are, where they come from, and what their eventual outcome is. So I'm gonna skip over this to get to the next kind of major section here, which will be the pituitary gland. So the pituitary gland is attached to your hypothalamus by a stalk called the infundibulum. We divide it into the anterior lobe and the posterior lobe. And the anterior lobe and the posterior lobe will produce or secrete different types of hormones. Here is the infundibulum, which is the stalk that will connect the hypothalamus to the pituitary gland. And your hypothalamus will control what is being secreted from the pituitary gland. The anterior lobe secretes 1, 2, 3, is it 7? Yes, it's 7 hormones are secreted from the anterior lobe: growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, and luteinizing hormone, and prolactin. These take you through the hormones that are secreted from the anterior pituitary and their target tissue, what they will eventually act on, and their principal actions. I do want you to know this. I want you to know what hormones are secreted from your anterior pituitary and what their primary actions are. And I'll let you kind of study that on your own, so you can go back and pause that slide. Really simply put, so prolactin promotes the breast to secrete milk. So during, right after pregnancy and delivery, prolactin will be secreted to start your breast or mammary glands to secrete milk. Growth hormone is really prominent during puberty in preteens, and it will affect all bone cells, muscle cells, and adipose tissue to increase in size and number. The gonadotropins are follicle stimulating hormone and luteinizing hormone, and they will stimulate the follicles to be made, whether that's sperm or egg cells. Adrenocorticotropic hormone acts on the adrenal cortex of the adrenal glands to secrete some of your glucocorticoids, which are responsible for the stress response. And TSH is thyrotropin stimulating hormone, will act on your thyroid to release thyroid hormones. The posterior pituitary hormones, it's a lot easier. They just store and release 2 hormones made in the hypothalamus. ADH, which is antidiuretic hormone. It promotes the retention of water in the kidneys. It's also called AVP. And then it also secretes oxytocin, which stimulates contractions in childbirth, and also milk being let down in lactation. ADH and oxytocin are produced in the hypothalamus, and then they are transported through this hypophyseal tract to the posterior pituitary, where they are stored until they will be released. Oxytocin is stimulated by the sucking of the mammary gland or the nipple, and if you're a mom, you know what I'm talking about. Oxytocin will allow that kind of letdown reflex to occur, where the milk will be let down. And ADH is stimulated by an increase in blood osmolarity, which has to do with kind of blood concentration. So this is a look how ADH and oxytocin are released, but they're actually produced in your hypothalamus, and they are stored in the posterior pituitary. The anterior pituitary is controlled by releasing and inhibiting hormones that are also transported by this hypothalamo-hypophyseal portal system. So your hypothalamus basically tells the anterior pituitary when to release these hormones or when to inhibit the release of them. Releasing and inhibiting hormones: corticotropin releasing hormone, gonadotropin releasing hormone, prolactin inhibiting hormone, also known as dopamine, somatostatin, thyrotropin releasing hormone, and growth hormone releasing hormone. Somatostatin is also known as growth hormone inhibiting hormone. And this is a great kind of look at these hormones that the hypothalamus releases. And again, they will be inhibiting hormones, or they will stimulate the anterior pituitary to release its hormones. and these will be the effects on the anterior pituitary. The final product regulates the secretion of the pituitary hormone. So we have a negative feedback inhibition, which basically this negative feedback loop, a perfect example of this, let's start in the hypothalamus. Its releasing hormone is thyrotropin releasing hormone, TRH, that acts on your anterior pituitary gland to release thyroid stimulating hormone, TSH, and that acts on your thyroid gland to begin growth of your thyroid and release thyroxine, which is a thyroid hormone. This negative feedback loop basically just tells us that if there's enough thyroxine in the blood system, that negative feedback will be sent up and have a negative feedback response on your anterior pituitary as well as your hypothalamus. And it'll tell them, hey, we have enough thyroid hormones, you can shut off the system. This is another look at the negative feedback loop. Now working with gonadotropin releasing hormone being released from your hypothalamus, acting on your anterior pituitary to release your gonadotropins, which are FSH and LH. They work on the gonads, the testes and the ovaries, to release your sex steroid hormones, which are all of your estrogens and androgens. And when the level of estrogen and androgen reaches to a certain point, that will tell or shut off this negative feedback loop. It'll tell your anterior pituitary, hey, we have enough, you can turn off the system, and it'll tell the hypothalamus to turn it off. This kind of flow chart is a great way to learn the hormones and where they're coming from and what the target organ is. So I would go through and take kind of each of the hormones and list out what the releasing hormone is, what it acts on, whether it's the anterior or posterior pituitary, and then what it will release and what its target organ is. The adrenal glands are found on top of the kidneys, and their adrenal medulla is the inner part, and the adrenal cortex is the outer part. The only thing I want you to know about the adrenal glands are the basic hormones that get released from them, and those were shown in kind of that previous initial chart. They'll release cortisol. In general, your adrenal cortex releases a lot of the hormones involved in like the stress response. There's mineralocorticoids, glucocorticoids, and sex steroids. Those are kind of the three differences of it. The adrenal medulla releases the epinephrine and norepinephrine, and these are activated by the sympathetic response, the fight or flight response. So this is the stress response that I was talking about. They will increase your cardiac output, your respiratory rate, your mental alertness. They'll dilate your coronary blood vessels. So epinephrine and norepinephrine are always released in the stress response, and they are released from the adrenal medulla. And this kind of takes you through that stress and the adrenal gland. And I'm going to kind of skip over the rest of this from here. This kind of shows you how it's activated. A nonspecific stress will act on your higher brain centers to tell your hypothalamus to release the releasing factor, telling the anterior pituitary to release the adrenocorticotropic hormone, and then it'll tell it to release the cortisol from the adrenal cortex. You can read through Cushing's syndrome on your own. It's chronically high levels of glucocorticoids, but I won't probably ask you about these in your test. Addison's disease is caused by inadequate secretion of corticosteroids. I think, and then the thyroid and parathyroid glands, this takes you through specifically what hormones are released from the thyroid and parathyroid glands. So this kind of will explain a little bit more about what is released. And I want to take you through just the hormones itself. Action of the thyroid hormone is to stimulate protein synthesis, promote maturation of the nervous system, increase rates of cellular respiration, and elevate your basal metabolic rate. Calcitonin works to tone down blood calcium levels. So calcitonin will take calcium out of the blood and store it. Diseases of the thyroid. Someone can be hyperthyroid, where there's too much thyroid hormone being secreted, or hypothyroidism. Iodine deficiency leads to overstimulation of the thyroid gland and growth of a goiter. It can also lead to hypothyroidism, which is low metabolic rate, weight gain, and lethargy. Graves' disease is hyperthyroidism, where there's too many thyroid hormones. And this takes you through the negative feedback loop, how iodine deficiency will cause a goiter. Basically, the growth of the goiter is found around the thyroid gland itself, and this is showing an endemic goiter caused by low iodine, so a thyroid hormone deficiency disease. Graves' disease, it's an autoimmune disorder in which autoantibodies bind to receptors on your thyroid gland. This causes growth of the goiter and stimulates an excessive secretion of thyroid hormones. Graves' disease and hyperthyroidism is kind of scary because it produces symptoms, sensitivity to heat, palpitation, and others. Many people with Graves' disease also have Graves' ophthalmopathy, where anatomical changes in the orbit of the eyes can cause bulging of the eyes. So you can kind of see her eyes bulging there, symptoms of hyperthyroidism. So this is a great comparison. This is also a really good chart to look at features and how they're different, whether you're hypothyroid or hyperthyroid. And again, the hypo means too little thyroid hormones are being released, and hyperthyroid means too many are being released. Parathyroid glands are embedded in the back of the thyroid gland. They secrete parathyroid hormone, and that promotes a rise in blood calcium. So parathyroid hormone increases calcium in the blood, and calcitonin decreases or tones down blood calcium levels. The pancreas and other endocrine glands, the pancreas is an endocrine and an exocrine gland. The endocrine cells will secrete glucagon or insulin, and they have opposite effects. So here's a look at the pancreas and the alpha and beta cells. Alpha cells secrete glucagon, beta cells secrete insulin, and again, they have antagonistic effects. Insulin is the primary hormone which lowers glucose levels in the blood, so it'll be secreted when blood glucose levels rise, usually after a meal. You don't need to know the actions of insulin. I just want you to know that insulin lowers blood sugar levels. Glucagon is antagonistic to insulin, so it'll be secreted by your alpha cells when blood glucose levels are low. So the purpose of glucagon is to raise blood glucose levels to the normal range. You don't need to know the action. I just want you to know how glucagon and insulin have antagonistic effects. Diabetes mellitus is characterized by hyperglycemia and the presence of glucose in the urine. There are two main types. Type 1 diabetes is caused by destruction of the beta cells, resulting in lack of insulin secretion. And type 2 diabetes is caused largely by insulin resistance or decreased tissue sensitivity to the effects of insulin. I do want you to know the differences between type 1 and type 2 diabetes. Gestational diabetes occurs in about 4% of pregnancies due to insulin secretion that's inadequate to meet the increased demand imposed by the fetus. The pineal gland, I think we're just going to go ahead and skip over the pineal gland altogether. If you're interested, it will secrete the hormone melatonin. It's secreted related to puberty, jet lag, and seasonal affective disorder. So this is the pineal gland, secretes melatonin. It's inhibited in the day and stimulated at night just to help you sleep. Other kind of endocrine glands in your GI tract, the gonads will produce testosterone, estrogen, and progesterone. These will be important during puberty. Your placenta produces HCG, which is what's detected on a pregnancy test if you're pregnant. And I think we're going to kind of end with that. I'm just going to take a look here and kind of take you back through that initial slide. So kind of this initial slide that, again, you first saw, understanding kind of the endocrine glands that we talked about, the major hormones that are produced, especially from the anterior and pituitary gland and what they act on, and then knowing insulin, glucagon, and there will be questions on your test about diabetes. So I really tried to slim this one down for the endocrine system. Thanks for listening, guys.